That moment your hand has already reached for the drink, the cigarette, the next hit. Before the thought has finished forming, your body decided first, you found out second. I'm Annabelle Cross. Welcome to MedHeads. Ibogaine comes from the root bark of the iboga shrub, West Central Africa, used ceremonially by the Bwiti for a very long time. And here's the first genuinely strange thing about it. Most drugs work by fitting one receptor, one key, one lock. Ibogaine walks into the building and presses every floor at once. It binds opioid receptors, both mu and kappa, as a mixed agonist-antagonist. It hits the same glutamate system ketamine works on. It touches serotonin transporters, sigma receptors, nicotinic receptors. Pharmacologists have been chasing its primary mechanism since the 1960s. The honest answer, it may not have one. But when your liver metabolizes ibogaine, it produces a compound called Norebogaine. And Norebogaine does something extraordinary in the ventral tegmental area, the origin point of the brain's dopamine reward circuitry. That's the neighborhood where addiction lives. Norebogaine sharply increases the expression of GDNF, glial cell line-derived neurotrophic factor, the brain's instruction to rebuild, right in that reward hub. Not a pleasure signal, a construction signal. And GDNF appears to trigger its own production, a self-sustaining loop, still running long after the drug has cleared. Which is why Ibogaine, a drug with a half-life measured in hours, produces changes people report months later. Ibogaine and Norebogaine belong to a class researchers now call psychoplastogens, molecules that rapidly promote the growth of new neural connections. So the working hypothesis, Ibogaine doesn't suppress the craving the way methadone does. It appears to open a window in which the circuit that generates the craving can rewire itself. Ibogaine doesn't quiet the pull, it rebuilds the wiring that makes it. If you search for Ibogaine results, you'll find very confident percentages, cure rates, 6-month abstinence figures. Be careful. A lot of those numbers cannot be traced back to any published trial. Here's what genuinely exists. The strongest study we have was published in Nature Medicine in January 2024, out of Stanford. 30 male Special Forces veterans with traumatic brain injury traveled to a clinic in Mexico and received Ibogaine alongside magnesium. Researchers measured them before and after. The results were, frankly, startling. Large reductions in PTSD symptoms, depression, and anxiety. Meaningful improvement in cognitive function and disability ratings. Effect sizes well beyond what existing treatments produce. 30 people, all men, all self-selected, all of whom flew to another country and paid to be there, with no placebo and no control group. That is not a failure of the researchers, it is what you're allowed to run when a drug is Schedule 1. Alongside that, a consistent set of observational studies from New Zealand and Mexico, reporting sharp drops in withdrawal severity and sustained reductions in use, in some cases a year later. Same caveats, small numbers, no controls, people who really wanted it to work. So, the direct answer, because you deserve one, is there a completed, published, placebo-controlled trial proving Ibogaine treats addiction? No, not yet. What there is, a strikingly consistent signal across every small study anyone has been permitted to run, a mechanism that plausibly explains it, and properly funded controlled trials now finally underway. The evidence isn't thin because Ibogaine failed the tests. It's thin because for 50 years nobody was allowed to run them. Now we have to talk about the heart. And I'm not going to soften this, because the people most drawn to Ibogaine are often the people at highest risk from it. Ibogaine blocks a potassium channel in heart muscle called HERG, the channel that allows the heart to electrically reset between beats. Block it, and the reset takes longer. On an ECG that shows up as a lengthening QT interval, a sufficiently long QT interval can tip the heart into torsade de pointe, a chaotic rhythm that can become cardiac arrest. This is not theoretical. There are documented cases at therapeutic doses in people with no known heart problems. One patient's QT interval went from 435 milliseconds to 588 within hours, and then arrested. A multi-site analysis of over 19,000 treatments found 6 deaths within 72 hours. Every single one was being treated for opioid use disorder. Not because opioid patients are unlucky, because opioid detox is the hardest case. Those patients arrive dehydrated, electrolyte depleted, sometimes on methadone, which prolongs the QT interval all by itself. The drug and the population stack risk on top of each other. There's one more variable nobody sees coming: A liver enzyme called CYP2D6 controls how fast you clear Ibogaine, and how fast you clear it is largely genetic. Same dose, same weight, 2 people, one clears it briskly, one is exposed far longer. What responsible practice looks like: full cardiac screening before dosing, electrolytes corrected, continuous monitoring throughout, not spot checks, magnesium specifically to buffer the QT effect, a doctor and resuscitation equipment in the building, full disclosure of every other drug you're on. Ibogaine in a hotel room is not the same substance as Ibogaine in a monitored clinic. The risk isn't the molecule, it's who is watching the heart. The law. In the United States, Ibogaine has been Schedule 1 since 1970, the category for drugs deemed to have no accepted medical use. And that creates a specific trap. You can't easily research it, and it stays in the category because it hasn't been researched. It's similarly restricted across most of Europe and in Australia. But it is legal, or simply unscheduled, in Mexico, Costa Rica, and a number of other countries, which is why a medical tourism industry grew up around clinics there. Quality across that industry varies enormously. There is no meaningful international regulator. And then, Texas. Texas committed $50 million to Ibogaine research, an investment its leadership intends to take to $100 million. That is, by a wide margin, the largest public investment in psychedelic medicine anywhere in the world. Meanwhile, the FDA has granted breakthrough therapy designation to Ibogaine derivative programs. Pharmaceutical developers are working on analogues engineered to keep the anti-addictive mechanism while removing the cardiac effect, the obvious prize if it can be achieved. Projected timeline. Pivotal trials over the next couple of years. An approval decision, assuming the results hold, around the turn of the decade, which is a long time if you're currently dependent on opioids. But it is a fundamentally different situation from the one that held for the previous 5 decades, which was nothing. The Schedule 1 category wasn't a verdict on Ibogaine, it was a research freeze that kept justifying itself. So where does that leave us? Ibogaine is the most interesting thing to happen to addiction medicine in 50 years, and the evidence for it is genuinely preliminary. Both of those things are true at once. Being excited and being rigorous are not opposing positions, they're the same position. If you're looking at Ibogaine for someone you love, the question that matters most isn't whether it works, it's who is monitoring the heart. If this is the kind of honest look at frontier medicine you want more of, subscribe, there's a lot more coming. And I'd like to hear from you. What is it about these early-stage treatments that the mainstream conversation keeps getting wrong? Leave it in the comments. I read them.